Hello, guys. Welcome back to our second lab. So, in the first lab, we see or we studied, basically multisim, but the purpose was, is to verify Ohm's law. And we used for that two methods, we can say. The first method we know is a traditional intuitive method. You just change the voltage on a resistor and measure the current at the same time, make a table, draw the relation, Ohm's law. Okay, measure the slope should be the resistor. We said that this is, sometimes tedious if you have a very, for example, a complex device that has nonlinear relation. You need many points, uh, and at that time you should have many points in your graph. Doing that, will be error prone. You will have mistakes. Better use parameter sweep. Parameter sweep is a super, feature in multisim that makes such kind of experiment very easy. Okay, but the problem is that parameter sweep is a simulation tool. It's not something that you can do in real life. I mean, if you are in a practical lab, uh, there is no way to do such thing. It's only in multisim. But the turn, the play around here is that you can do that something similar to parameter sweep, but using oscilloscope. I mean, at the end of the day, we want to measure or want to, have a relation between V and I to verify Ohm's law. Okay. So basically, in oscilloscope, there is a mode of operation called XY mode. So let's explain what's XY mode. So basically, most of the scope has two channels. You can input two signals at the same time to the oscilloscope. Okay, then oscilloscope will just draw the two signals versus time at the same time on the screen. Something is like what we see here. Good. So basically, let's assume for a moment that one of these signals is V, the voltage, and the red one, for example, is the current. So the blue is the voltage, the red is the current. Just for a moment, okay? And both of them now are drawn versus time. I mean, if you want to measure, the voltage value at a specific time, you go to that time, go up and measure. For example, at that time, if we go up here, this is the value of the voltage, and so on. Good. This is not basically, the linear relations that we are expecting to see in our experiment verifying Ohm's law. We need something like this. Then we measure the slope, and the slope should be equal to the resistor R. Okay. So now let's go back to this story about XY mode that I started with. What's XY mode? In XY mode of operation, this is basically called, YT mode, okay, in which the signals that you are inputting to the oscilloscope will be drawn versus time. In XY mode, we will do something, or the oscilloscope will do something, or will show something else on the screen. It's basically will draw the two signals versus each other. So, for example, you have two channels, channel 1 and channel 2. Okay, it will take channel 1 and draw it versus the input at the channel 2. That's why it's called the XY mode. Or you can call it channel 1 versus channel B. Or some oscilloscopes call channel 1 channel A and channel 2 channel B. So they call this mode XY mode. They call it AB mode. Okay, like multisim. So this is basically two screenshots from multisim. Here is YT mode, and here is AB mode. In that case, if this is channel A, and that's the case, by the way, and this is the channel B, this axis here is the current, and this axis here is the voltage. And this is Ohm's law. And the slope here is the resistor R. Good. Now we have two questions now, or two problems we can say. The first one is that oscilloscopes measures only voltages. They are voltmeters. Always the input current to the oscilloscope is zero. You can't connect oscilloscope in series with something. It will be open circuit for sure. Okay. So how can we measure current? You remember to measure current we put ammeters, and the ammeters we put them in series with the resistors or with the components that we want to measure its current, whatever it is. So the trick here is that we can use Ohm's law again. So we know that if you have a resistor R, here is the current that flows through R, here is the voltage across R. So V is equal to Ri. If R is equal to 1, then V will be equal to I. So if you are drawing or if you are inputting to the oscilloscope or if you are connecting one of the channels of the oscilloscope to these two terminals here of the resistor R, the signal that you see on the oscilloscope, which is V of R, is also I of R, the current through R. Why? Because R is equal to 1. So that's exactly what we're gonna do here. So this is the resistors that we wanna basically verify Ohm's law, according to it. I mean, the slope should be 1 kilo or 1,000. Okay. So basically, here is the oscilloscope. Here is the CRO. It has some weird name in multisim. I'm not sure why. But this is basically the oscilloscope in multisim. It has two channels A and B. So we want to verify Ohm's law across the resistor R1, the 1 kilo ohm. So we're going to connect channel A across its terminal to measure its voltage. So channel A now is measuring the voltage of R1. So channel A, VR1. Now we need channel B to measure the current through R1. But here we see that R1 and R2 are series. So R1 and R2 in the series. So the current of IR1 is equal to the current of IR2. IR1 equal to IR2. And VR2 equal to 1, which is the value of R2, multiplied by R2. So it's equal to IR2 equal to IR1. So if we measure the voltage across R2, this is basically the current through R1. So we should now connect channel B across the terminals of the resistor R2. It has two terminals, that point, which is basically the negative of channel A. So basically do that. Just connect the negative of channel A to the positive of channel B. And the other terminal of the resistor, which is the ground, to the ground or the negative terminal of channel B. Now, if we do that and click run, we're gonna see something like this. And if we click this button here, AB button, we're gonna see something like this. And the slope, if we measure the slope, it will be 1,000 or 1 kilo. Okay, maybe now you are asking yourself how the oscilloscope will do that, how he draw current. You want to understand what is basically this mode, this AB mode. So I do here an example. It's not our example. I mean, the slope here will be 2, not 1,000. Okay, but you will get the idea with some simple numbers, we can say. Okay. So let's assume channel B has this red signal and the channel A has this blue signal. And we are in AB mode right now. So let's now imagine we are the oscilloscope And let's see what will be the oscilloscope is doing to draw A and B in that mode, AB mode. How he gonna do this for us, this linear relation. So let's see how. So basically, in that mode, the oscilloscope, somehow will pick at the same time the value of I, channel B, and the value of channel A, which is V. Then these two values will be like coordinates for some point that it's gonna draw on the screen. So for example, let's start from here, that point. You cannot start from anywhere. I will let you to start from anywhere and you will get the same results that I'm gonna get now. So let's start from here. So here I is 0 and B is 0. So now the oscilloscope will draw or light up a point on the screen at a location 0, 0. So you will have this is the screen right now. I will be the horizontal axis, which is we are in AB mode. So A vertical, B is horizontal. And V is in the vertical axis. 0, 0. So this is our first point. It has coordinates 0 in X or 0 in I and 0 in V, which is Y. Good. Now, let's go a little bit higher. I have the corresponding point at the same time. V is 1. So have and 1, this is the point. Then, when I is 1, at the same time, V is 2. So 1 and 2. Then, when I is 1.5, this is 3. 1.5 and 3. When I is 2, V is 4. I is 2, V is 4. And you can just draw it like this. Here is the points again. This is what the oscilloscope will show. You may say, how about this half? It will be the same as this half. Let's see. Let's check. But it will be the same. But let's check. Again, when I is 2, V is 4. I is 2, V is, we did it already. When I is 1.5, this guy is 3. 1.5 and 3, same point. When I is 1, V is 2. I is 1, V is 2. We have same point. I is half, V is 1. Same point. Finally, I is 0, V is 0. Same point again. Why? Because, the positive half cycle of both I and V are symmetric around the maximum. This part is equal to this part. That's why you will get the same line, we can say. Now, for the negative, we have still the same concept, and the line should be extended. It will not be a separate line with separate slope. No, it will be the same line that you get in the positive. So when I is minus half, V is minus 1. This is minus 1 and this is our minuses. So half and minus 1, something like here. Then minus 1, minus 2, minus 1 and minus 2, like here. Then minus 1.5 and minus 3. And finally minus 2 and minus 4. And it will be just extension. What is the slope here? Basically just take any point. So here 2, here is 2, here is 1. So the slope is 2 by 1 is 2 ohms. This is of course not our example. Our example, we should see 1 kilo ohm as a slope. But this is simpler with simpler numbers. Okay. This is basically how AB would work. in any oscilloscope, not just of course the multi-sim oscilloscope, the the practical oscilloscope also have this mode. It may be called XY mode, not AB mode. That's fine, but it's the same operation. And this is basically parameter sweep. This is just a hint, not even a second, a moment, and you will see that it's even easier in setup than parameter sweep. In parameter sweep, we should choose a source. You might have several sources. You should choose, the dependent variable, or the thing that you want to measure against the source. But here, you just connect V1 or V and I, and then just click AB, you will get the relation. Okay, guys. So this is basically the theory behind, or the idea behind our lab today, our experiments today. So in the next video, we're gonna see the exact setup and how we're gonna do that, or make this setup on multisim, and how to see and verify such a kind of method. Okay, guys. So see you in the next video. Bye bye.